This video is over chapter 16, and in particular example 174. In example 174, we're going to find a non-zero vector in the null space of each of these matrices. Also, while we're doing that, I am going to explain a little bit of the proof of theorem 173. So what we're going to do in 2.5 of these examples is simply mimic the proof of theorem 173. So we want to find a vector that's not the zero vector that is the null space of this matrix. So I will start to write the vector here. Now if you look at the proof is based on finding the first free column of the matrix. For this first example, it will be the last column. And so one of the things that's observed in the proof is that when you ignore this column in this row, you have the 3 by 3 identity matrix in the upper left corner. Wherever you find your first free column, then you have an identity matrix in the upper left corner wherever you find that. So here we have the fourth column is the free column. And so according to the proof, we put a 1 as the fourth component. If there is anything after 4, and there's not, we would put zeros, but there's nothing. So now we go up the column and we see a 3, so we write a -3. We have a -2 in the 2, 4 place, so we'll change the sign and put a 2, and then a -1. So if we multiply this matrix times this vector, we have 1 times a -1 is -1, then we have 0, 0, 1, so we have 0. When we come across the second row of the matrix, we have 0, 2, 0, -2. Coming across the third row gives us 0, 0, -3, 3. And finally across the fourth row, because the fourth row is all zeros, we have a 0. And so this vector right here is a non-zero vector in the null space of this matrix. Part B is similar. We have 4 columns, we have 3 rows, we have 1 free column. It is the third column. So we're going to find a non-zero vector in the null space using this third column. So again, we look at the third column, we ignore everything to the above it and to the left, and we have the 2 by 2 identity matrix right here. So what does our proof say to do? It says in the third place, because it's the third column, make the third component a 1. Everything below the third component is a 0. And then we go up the column, changing the signs. So when we had the 4, we put a -4 here. With the -3, we change the sign and make that a 3. Now multiply this matrix times this vector, and we have 3, 0, -3, 0. That gives us a 0. Across the second row, 0, -4, +4, plus 0. Across the third row, 0, 0, 0, 0. We multiplied a 3 by 4 matrix by a 4 by 1, so we get a 3 by 1. So that's why we have the 0 vector in R3. This matrix here is a little bit different than the previous 2 examples. We only had 1 free column. Here we have 2 free columns. We have the second one, and then we have the fourth one. The proof of theorem 173 is based on the first free column. So the first vector that we find, we'll find the same way that we did with the previous two examples. So here we have our second column is a free column. So we'll make the second component a 0. Everything, or the second component a 1. Everything below it is a 0. This vector is going to live in R5 because this matrix has 5 columns. So our vector has to have 5 rows. And we are right here. And so the upper left-hand corner, which is just this entry here, is the 1 by 1 identity matrix. We are here at the 2, 2 place. We look up and we see a 2. So we make this a -2. And if you multiply this matrix times this vector, you're going to get the 0 vector. You're going to, again, it's going to be the 0 vector in R3 because we have 3 rows and we have 1 column. So our matrix, when we multiply this, will be a 3 by 1. So the 0 vector will be in R3. But now, and you'll do this in your homework as well, we want to find a second vector in the null space of this matrix. And we're going to use the 4th column for this. Now when we do this, what we're essentially going to do is ignore the second column here. We're going to pretend it doesn't exist. We've already worked with it. And so 1, 2, 3, 4. So our 4th component will be a 1. Everything below 4 will be a 0. Now, since we're ignoring the second column, what we're going to do is we're going to make the second component a 0. Now, if we ignore the second column and we're looking at this 4th column and you look at the left, what you have is you have the 2 by 2 identity matrix because we're ignoring this column. And so we are right here in what we're pretending is the 3, 3 position. And we go up and we change the signs. So we have -4 and then we have +3. Again, we're pretending that 2 doesn't exist right here, that the second column doesn't exist. And so now we found another vector in the null space.